Hello, and welcome to another episode of NASA Science Live. This is an opportunity for you to interact with NASA experts and have your questions answered in real time. I'm your host, Denise Hill, and we are taking you all the way to Australia, where there's a total solar eclipse happening right now. This event is unique and rare because it's both a total and annular eclipse, which is known as a hybrid eclipse. We're going to see real-time views thanks to our friends at Time and Date. We're going to talk about the sun and answer some of your burning questions. You can send us questions using hashtag AskNASA on social media or drop them in the comment box wherever you're watching us from. The sun touches everything. It is Earth's life force. The sun-Earth connection is a vital part of our lives and society. It influences a variety of systems on Earth, like agriculture, economics, climate change, politics, food and food scarcity, as well as the physical, mental, and emotional health of humans. We see its influence throughout our culture in art, music, religion, fashion and sports, and a host of other trends. During tonight's event, we're also going to share a special upcoming opportunity for you to participate in sun science. So let's jump right in. I'm joined today by NASA sun scientist, Dr. Kelly Kirk. Kelly, thank you so much for being here today.
Thank you so much, Denise. It's my pleasure.
So I think we should start off by first explaining the reason why we're here, the eclipse in Australia. So can you tell us how solar eclipses work and why this one is called a hybrid eclipse and what that even means?
Definitely. Yeah, let's get started. So what a solar eclipse is it's an alignment and a dance between the moon, the earth, and the sun. So the earth and the moon is in between the earth and the sun and casts a shadow on the earth. And that's a total solar eclipse when it completely blocks out the sun, and that's because it's close to Earth. And we go through as the moon goes around. We don't have one every month, but we do get them occasionally. We also have an annular eclipse. And an annular eclipse happens because the moon doesn't stay in a perfectly circular orbit. It sometimes is a little bit further away. So it doesn't completely block out the sun. So it leaves this ring of fire around the sun, like in the image that you're seeing here in that annular eclipse. And this eclipse in Australia is a hybrid. So part of the path of totality is going to see totality. So you're going to completely block out the sun. Another part is going to see the actual ring of fire. And so that's why it's a hybrid. Based on the curvature of the Earth and where you are on the path, you're either going to see the total or you're going to see the annular eclipse.
Okay, so eclipses are super cool events to see in the sky, but why do scientists care about eclipses and what can we learn about them during these events?
Great question. So what happens during these events is that we can actually see with our own eyes the sun's corona, or hot outer atmosphere. And that's something that we, before the space age, we really couldn't do any other way. So we were able to study things that flow off of the sun, seeing this constant solar wind during these eclipses. We also did things like experiments in general relativity and discovery of helium and other elements of the sun. So there's a lot of different things that you can do with eclipses.
So speaking of sun science, is there anything happening in Australia right now?
Actually, there is. There is a kite experiment that is going on during this eclipse. So it's a new platform for us to actually take data from. We've done things before in rockets or balloons or spacecraft, but this is now a kite. And you're shown here as a picture. This kite is 21 feet across, and it'll fly around 3,500 feet, and it will actually take a spectrometer, so it'll split the light up, is the instrument aboard, as it looks at the sun and try to find that flow that I was talking about, that constant solar wind, and how that escapes the sun during this eclipse. And if it's successful, they'll hopefully fly it again in 2024 when the eclipse comes to North America.
That's so cool. Who knew flying a kite could be both fun and educational? I love it. So I mentioned at the top of the show that there will be opportunities for people to participate in sun science. Can you tell us a little bit about the Heliophysics Big Year, what it is, and how folks watching can get involved?
Definitely. The sun and all of us are in for a big year. Starting in October of 2023 with the annular eclipse that goes across the US and then down into Central and South America. Then going to the April 8th, 2024 total solar eclipse, and then finally ending the long big year, December 2024, when Parker Solar Probe goes to the closest approach to the sun, 94% of the way to the sun, to study that outer atmosphere that we're going to see here in a few minutes with this total eclipse. And so this year is a way that we can all belong in science and all belong to learning about the sun and all the different ways that the sun touches our lives. And the term big year actually is a birding term, a citizen science birding term that is studying as many species as possible of birds in one year. And what we're challenging folks to do is to study as many different things or relate to as many different things as they can about the sun. So can you see an annular eclipse? Can you see a total eclipse? What about aurora? What about seeing a solar flare go off? What about participating in a sport or another event that relates you to the sun?
And you mentioned citizen science, and citizen science is a big part of how folks can participate in the Heliophysics Big Year. A few specifics come to mind, like Eclipse Soundscapes is a citizen science project that allows you to participate in eclipse research by observing and collecting audio recordings during upcoming solar eclipses. You then take the data and analyze it and determine how eclipses may affect the ecosystem. And to learn more about that one, you go to eclipsesoundscapes.org. Another one is called the Nationwide Eclipse Ballooning Project. And this one will engage teams from a range of colleges and universities in an adventure in scientific ballooning. These teams will participate in scientific ballooning during the upcoming annular and total solar eclipses in 2023 and 2024 across the eclipse path. Student teams will use innovative balloon systems to conduct experiments. To learn more about this project, go to go.nasa.gov/NEBP. All right, thank you, Kelly. We'll come back to you in just a moment to answer some of the questions we have coming in. Don't forget to submit your questions using hashtag AskNASA or pop them in the comment box on the platform that you're watching. So as Kelly just mentioned, there's a big year of sun science ahead of us. Mark your calendars, because on October 14th, 2023, there will be an annular eclipse where the moon only blocks the center part of the sun and creates what looks like a ring of fire. And then on April 8th, 2024, millions of people across the US will have the chance to see a total solar eclipse. Where will you be? NASA has some new maps that could help you decide. Let's take a look. Yeah. I am so excited for these upcoming eclipses. And truth be told, I've never seen a total or an annular eclipse. But for the annular eclipse coming up later this year, I know exactly where I'm going to be. I am going to be in Albuquerque, New Mexico, and I am so excited. So to take a closer look at the NASA eclipse maps in more detail, you can visit go.nasa.gov/US eclipse maps. Let's chat with a NASA expert who is in Australia right now for tonight's solar eclipse. We are joined by planetary scientist Dr. Henry Throop. Thank you so much for being with us, Henry.
Hey, thanks for having me here.
So you're in Australia right now. Can you tell me exactly where you are?
So I'm at Exmouth, Australia, which is in the Ningaloo Peninsula in Western Australia. This is a really remote region of Australia. It's a long way from the closest city, Perth, closest large city, Perth, which is itself a very remote capital city. So there are thousands of people down here who have made the trek all the way out to Exmouth, waiting for this for totality, which is going to be coming up here in a little more than an hour. A little less than an hour.
That's so cool. That is so cool. It looks, I see a ton of equipment back there. Do you have anything with you, and what are you going to be doing?
So I have a solar telescope here myself. I'm going to be watching the sun as it disappears in H alpha, which is the wavelength where you see a lot of the activity of the sun. You see a lot of these features on the sun, both on the disk itself and off to the side. There are thousands of people here with their own telescopes, recording the sun, taking pictures of it in various ways. But most of the people here are not scientists. They are fans of the sun and are here for the excitement of being here at the eclipse. There are thousands of people who've been coming in all morning. Let me just give you a little tour of the site here. You can see. Going here, we are right next to the ocean here. A great place for seeing whale sharks. We're not going to see those today because everyone here is looking at the eclipse instead, and you can see all the thousands of people behind us there.
That is awesome. I am so jealous right now. That looks so awesome. Okay, we're going to let you go so you can go enjoy the eclipse and see it firsthand. Thank you so much for joining us. So here's a question. Since the moon orbits around Earth roughly once per month, how come we don't have 12 solar eclipses every year? So glad you asked. Here's why. All right, so many of you watching have questions about the sun and about eclipses. So let's get to some of those now. Remember, if you have questions, you can send them to us on social media using the hashtag AskNASA, or just drop them in the comment box from wherever you're watching us from. So now I'm back with sun expert Dr. Kelly Kirk, and we're about 30 minutes away from totality. As a reminder, you are seeing real-time views of the eclipse in Australia, thanks to our friends at Time and Date. Kelly, let's tackle some of these questions that are coming in online. But first, I want to jump the line and ask a question myself. I am curious about how do you watch an annular eclipse and a solar eclipse safely?
That's a great question because really safety is our number one priority here. So for the annular eclipse, you will always have to use a pair of solar viewing glasses. These are not sunglasses. There are specific glasses that are made to a certain standard so that you can look at the sun through the annular eclipse. Or you could make an indirect viewing device, which means that your back is to the sun and that device is in front of you, whether that's a strainer, like a kitchen strainer, or even your hands. You can make a strainer this way and project the image of the crescent moon or the ring of fire onto a wall or a floor, things like that. For the total solar eclipse, whenever the sun is only partially eclipsed, you must again have those glasses, the safe eclipse glasses, not sunglasses, to watch, or the indirect viewing method. And during totality, we want you to be able to look directly at that corona, directly at that sun's corona, the beautiful atmosphere that we study and that really flows out towards us and connects us to the sun. So that's how you safely view an annular and a total solar eclipse.
Okay, so I think I got it. So for an annular eclipse, eclipse glasses the entire time or indirect viewing method the entire time. And for a total solar eclipse, glasses, indirect viewing until totality, and then back to glasses, indirect viewing.
Exactly.
Got it.
You got it.
All right. Our first question from viewers online is from Mitsuhari Ida. And if I mispronounced that, please forgive me. On Twitter, she's asking, why are some eclipses longer than others?
That's a really good question. And it does have to do with how they line up. In the video that we saw just a little while ago, to get the eclipse, you have to have the moon and the sun and the earth in that direct straight line. And so sometimes it's just a little bit off in one direction. So you get some of the shadow, but not a lot. And based again, where that position actually is how long you get the eclipse. So about the longest we could ever get theoretically is around 7 minutes, 7 minutes of eclipse. Oh, wow. We're only going to get around a minute today in Australia, but we're very lucky to get about 4.5 minutes next year in 2024 wow. for the total eclipse.
Excellent. So looking at what we're seeing now, can you tell us what it is we're seeing, what we're looking at?
Yeah, so right now what we're looking at is the yellow or the white ball is the sun. And we have the black crescent on the bottom is actually the moon's shadow going across, or the moon's disk that you see blocking out the sun. So we've already made what is called first contact. So when the first looks like there's a little bite taken out of the sun by the moon. And we're moving through towards what will become the second contact, which meaning that disk of the moon will touch the other side of the disk of the sun.
Wow, that's amazing. It's absolutely beautiful. All right, so let's head back to questions online. Prince Z on YouTube asks, how many times does this happen and how long does it last? And what impact does it have on our planet? So let's take that one at a time. How many times do total eclipses happen?
So there is a solar eclipse about every 18 months. Somewhere on the earth, but the earth is large and there's a lot of bodies of water. So sometimes it's over water and not land. So it's relatively common, every year and a half. But in one place, it averages around 375 to 400 years to get one in a specific place. So it's special to have it in your place. And you could probably find one if you flew somewhere in the world every 18 months.
Okay. And how long, you kind of answered this, how long they last, and if you want to elaborate on that, talking about like the different time frames that you mentioned before.
Yeah, definitely. So they can last anywhere from a few seconds or a minute to actually, up to 7 is the 7 minutes would be the longest one, but that one's not going to happen for quite a long time. So really, about 4 minutes is 4.5 minutes we're going to see along the path in 2024.
And is there any impact of eclipses on the planet, on Earth?
Definitely. So we actually use them as a scientific study, both here and elsewhere. So when you're experiencing a total solar eclipse, and this is one of the things that, as beautiful as this image is, it can't quite capture, is it's a full body experience. So it becomes cooler. So there's a temperature change. It also gets darker. So animals that normally go to sleep at night go to sleep because they think it's nighttime, and then they wake up after the sun comes back up. So a rooster would crow, or crickets would chirp and stop chirping, and all of these things. So it does have an effect on the Earth, and we're actually using it also in 2023 and 2024 to study the ionosphere, or layer of the atmosphere, where we actually use for a lot of communications, and how that instant day-night shift. We're actually using it as a way to study that effect on Earth.
That's awesome. That's amazing that it does have this impact and that animals and nature responds. I think that is so cool. Okay, so next question. Tunisia Tucker on YouTube asks, these really seem rare. So when is the next hybrid eclipse?
Oh, that's a good question. I actually don't know when the next hybrid eclipse is. I'm going to have to look that up, and we'll have to find that and put that on the NASA website.
Do you know how rare they are?
They do tend to be a little bit more rare than the total or annular eclipse, because I think they have to happen at just a certain kind of geographic location. So they're a little more rare than the total or the annular.
Carolyn Craig has a great question that I also have. So, like, what equipment do we use to determine when an eclipse like this is going to happen, and how far in advance are these predictions made? How far in advance can we predict when an eclipse is going to happen?
That's a great question. And because we understand the orbital dynamics of the moon and the sun and the earth, we can actually predict them out very far. There are maps of, hundreds of years, if not thousands of years of data, because you can project where the sun, the earth, and the moon will be. And so we rely on that predictability. And actually, in millions of years from now, the moon will be moving away so that it will not be able to actually do eclipses anymore. But that's really a long time away. But eventually the moon will not be able to cover. Yeah.
That is so
so we
fascinating.
Can a long time.
Oh, wow. That's really cool. Mickey Manoia on YouTube asks a question you kind of already answered, but I'd love for you to elaborate on it. It's about like nature, and it's like, will the birds go silent? And do we know why? Like, what do they think is happening, since it's only for a short amount of time?
Right. So it's for a short amount of time, but you kind of have a somewhat normal lead-in to nighttime. So when you're experiencing a normal nighttime, the sky gradually gets dimmer. You start to see with a sunset maybe a pink or orange or beautiful colors, and so you know how to kind of get ready for bed, or get ready for it to be nighttime, and so it's not it's. The light is eerie, actually, as you go into the solar eclipse. It's not quite the sunset, but it has some characteristics of the sunset. So I'm not an animal expert, but I would guess that they would just sense that it is the same kind of characteristics of nighttime. So, okay, let's get ready for bed. And then suddenly the sun comes back up and they're like, well, yes, that was the shortest nap ever.
I love that analogy. That is amazing. And it makes sense. Kevin Boaknight on Twitter asks, does it go completely dark during totality?
It gets very, very dark. And like I said, that the light is very eerie. When I saw my first total eclipse in South Carolina, it was definitely that like gray, dark around the eclipse. And then there was this eerie all around the horizon, like orangey light, much like a sunsetty type colors. So it was very eerie light, and it is significantly dark.
Oh, that's excellent. I'm so looking forward to it. It just sounds so artistic and creative and amazing. This is a good one. So Mike Meck on Facebook is asking for us to go in a little bit more detail on actual safety and eye safety on the glasses during the eclipses. Great. So like when you were talking about, thinking about like in Australia, they're having both a hybrid and a total eclipse, so annular and total. So can you talk about the differences and go through that again?
Right. So where our friend Henry was, they will have a total solar eclipse. So right now it's partial. The view that you're seeing from time and date is a partial eclipse. And so at that point in time, you must have your safety glasses on. Your eclipse glasses must be on, or again, indirect viewing method, one of those two things. So Henry right now should only be looking at this through safety glasses. And then once it becomes total, he can take them off and be able to look at the sun and look at the corona and see what it's doing. I'm very interested to see what we're going to see. And then once he knows that the moon is moving back and you're going to see more sunlight, that's when you have to put your glasses back on for the total. Now, if you were to go kind of a little bit further along the path of this eclipse, that is where you're going to see the annular eclipse. So they're actually not going to get an annular and a total in the same place. They'll get a total in this place, but then further along the path, it will become annular because the curvature of the Earth is then making the moon just that slight farther away. So it just, again, doesn't block out the whole entire sun. Those people who are further along the path of this eclipse who are getting the annular must keep their glasses on the entire time. So they will not be able to see the corona themselves.
Okay, excellent. Thank you for clarifying. Adam F. on Twitter asks, how wide is the path of a total solar eclipse in general, would you say?
Right. In general, it could be normally around a couple 100 miles or 100 miles. So I think it's 150 in 2024. So it's about that wide. It's not super wide, but it's a good distance.
Okay, next one. Sunrit Ghosh on YouTube asks, so this is a hybrid eclipse from Australia. So in Australia, it's a total eclipse. Where's the annular eclipse taking place? Do you know? Do you happen to know?
It is, I think, Papua New Guinea, like as you go up the path of totality. So I don't have a visual of the path right now, but yes, as you would go further up the path, you would see something again much more like you see on the right to the annular eclipse, that ring of fire.
Okay, so, and this is a really good question. So Bray Kimberly on YouTube is asking, are there special cameras or lenses made for cameras to record solar eclipses?
There are, and this is another thing that we have to worry about with safety, or at least plan about for safety. And so we don't want to just use our glasses with this. So there are special filters for telescopes, binoculars, cameras that you can get. You can research and find appropriate filters to put in front of those at the entrance of the sun. So we don't want to use our glasses in this case. We want to use specific things designed for telescopes, phones, or binoculars.
Excellent. Okay, Mohammed Elma on YouTube asks a question about the geometry of eclipses. So why is the sun and the moon from our perspective exactly the same size?
That's great. And it's a matter of distance and size. So the moon is the right distance away and the right size because the sun is bigger, but it's so far away. So it's 93 million miles away versus the moon being much closer. So it's the same that I've been explaining it as the fact that when you put your hand right up in front of your face like this, you can black out almost and see everything. So the moon's just that close, where if you put it further away, you can see, around it and everything. So it's just the fact that the moon happens to be the right size and shape and then very close. And so that's why it's able to black out the whole huge sun.
It's all a matter of perspective, I hear you saying.
Yeah.
All right. Adriana Lazar
yeah.
On YouTube asks, why is the annular eclipse called a ring of fire? And then she also sends us love from Arizona and says, we rock.
Yay! I love Arizona too. So why they call it a ring of fire is that it looks like there is that orangey ring of fire around the moon, as this image shows. It looks like kind of something's on fire in a ring. So that's why it's called the ring of fire eclipse when it's an annular eclipse.
Right. So the sun is not actually on fire. There's no actual fire. It's just describing what it looks like is what you're saying.
Exactly. The sun, yes, the sun is safe.
Excellent. SimCity on YouTube asks, if the moon moves on a horizontal plane, why are we watching the moon rise from the bottom up? So does the moon move on a horizontal plane?
Right. Okay, so the moon is inclined. So if the Earth goes on this plane, it's inclined. The moon is inclined. There we go. There's the graphics. Look at there. Is inclined as shown in this graphic. So it doesn't always hit. The shadows doesn't always hit the Earth, and that's again why we don't have 12 eclipses every year, because it's slightly off. And due to that geometry, that's why it doesn't do. So it's not in necessarily a horizontal plane, and that's again why we don't get eclipse every month.
All right. Chrissy Astromilly on Twitter asks, what observations are being done from space of the eclipse? And then anything from the other side of the moon or the moon shadow that you know of?
Oh, cool. All right, great. So for the assets that we have in space that are watching the sun, they aren't necessarily in the path of this eclipse, right? They don't necessarily live right over Australia per se. But we do make instruments that simulate an eclipse. So things called coronagraphs. So we basically make a false moon that kind of looks like a thumb that goes up in front of the camera and blocks out the center of the sun, so that then we can go and see the corona that's coming off of it. So we do make space-based eclipse observations, but they're not the natural eclipse observations. They end up being manufactured. We do sometimes in certain telescopes like Hinode, and I think SDO as well, Solar Dynamics Observatory, are able to get eclipses in their orbit as well, but they don't normally coincide with the ones that we're talking about here. Because they're on a different orbit, they have a different trajectory that line up the spacecraft and the moon and the sun.
Excellent. Our team behind the scenes got us an answer to the question about why today's annular eclipse is visible. Where today's total solar eclipse is visible. So the total eclipse is visible in Australia and Southeast Asia. The annular eclipse is visible over the Pacific and Indian Oceans, and a partial eclipse is visible from Australia, Southeast Asia, and Antarctica. So there's that. Thank you, behind the scenes team. Love it. Rebecca Gergens says she is watching the live solar eclipse with her class in Macau. And if it is daytime in Australia, why does the telescope feed look like it's nighttime? So why is it all dark? Why is it black?
Well, yeah, that's interesting. So they are looking, I think it has to do with the filter of the telescope. They're filtering out the light so that they can, I think this is the H alpha feed, which really focuses on a specific part of the light. So you get that heat from the sun, because I'm starting to see a prominence appear in the lower left-hand corner. So just past there, their little thing that's kind of shooting out, a prominence there. That kind of indicates that that's the wavelength or the type of warmth of light that we're looking at. So that's why it probably looks dark, because nothing else out there is that warm. But yes, it is daytime in Australia. But as the sun's covering up more and more, it will, at least in Exmouth, will become darker and darker, and again experience a false night for about a minute.
Excellent. How you doing? Are we killing you with the questions? They are coming. They are great.
These are great questions.
All right, I have a really good one from Angel Shinari. She asks, next year, totality will be in Mexico. So I'm assuming it's a total solar eclipse. And she's wondering if you know how long will totality last then. Any ideas on that one?
So it's around 4.5 minutes. And there are great resources online that you can find your city and state and find the exact timing for that location. And that's actually another important part of planning your eclipse viewing, is to go to those trusted sites and find the list of the times that both the length of totality, so that you can enjoy that corona and soak up all of that beautiful solar wind and that and all the magnetic fields that are moving things around. And that you'll be safe, that you'll be able to know when you need to put your glasses on, and to plan to make sure to be there well ahead of time so that you don't miss it.
And will NASA have resources that kind of help people find places and times and that kind of information?
Definitely, there are some resources that will help with things like the map. Will show you where there is the path along the path of totality, and what cities and states will experience totality. And actually, the entire contiguous U.S. will have a partial eclipse that day. So even if you're not part of the line that goes from Mexico to Texas, up through Oklahoma, Arkansas, Missouri, Illinois, Indiana, Ohio, Pennsylvania, New York, Vermont, New Hampshire, and out through Maine, and then Nova Scotia, in Canada, all those places, you'll get a total solar eclipse. But the entire continental United States will get some type of partial eclipse as well. And then the other side of that, on the left hand side, is the annular eclipse that will happen in 23.
That is so cool. And it kind of brings us back to like the heliophysics big year, like the sun touches everything. And in the US, like that is such a unifying and just a beautiful moment when everybody will get at least some portion of an eclipse. That's really cool. Before we pop to the next question, we want to thank Time and Date for this amazing feed that we're watching. And we're watching it live. We're watching the magic happen live. I'm so excited. Let's go to a next one. Morts730 on Twitter asks, what changes the duration of totality? So what makes it different?
Right. Again, it's all about geometry. So it's all about where your place in space. We all belong here, and the place in space does matter. So depending on exactly in the orbit of the Earth and the Sun and the Moon and how they line up, is how long you will get totality for. In this case, how it lines up, and because it's at a place where the moon shadow is moving very quickly, it only lasts for around a minute. When you're closer to the equators, it takes a little longer to move across that land, so it goes a little bit slower. You can get a little bit longer durations, and then again, it's all about that lineup between the Earth, the Moon in the center, and the Sun. And so as it goes around, it will create, different lengths of time in the eclipse.
Oh, that makes sense. Yeah, that's a great explanation. Nat A on YouTube asks about eye safety. So what happens, or what could potentially happen, if we look directly at an eclipse or look directly at the sun?
Right. So looking directly at the sun, which you should never do, would cause the back of your eye to burn in the image of the sun. And so you would have a blind spot in the area where you had viewed the sun. So it is not advised to do this. So make sure that you have your safety glasses or an indirect viewing method, if you don't have safety glasses, in order to make sure that you can safely do this and safely see afterwards.
Yes. So the takeaway is be safe. Got it. Love that. The Plastic Effect on YouTube asks a really good question. So are lunar eclipses or solar eclipses more common? Is one more common than the other?
Oh, that's a good question. Wow, I haven't ever thought of that. I was like, oh, you just put that on me, because a lunar eclipse happens when the Earth is blocking the sun from the moon, and so that is why you're getting that darkness or that eclipse. Is it more common? I think it is, but my brain is not functioning. Maybe we need some behind the scenes, some behind the
Yeah.
scenes phone a friend.
I love it. The plastic effect. You may have stumped NASA scientist. That just goes to show you, like, we don't know everything. I think these are great questions. We have Kelly on the spot. She doesn't have any of these answers. She's answering you're doing an amazing job, my friend.
I mean, really, that's what a scientist is. It's about, figuring out how to do it and finding the right source of information, right? So it's not necessary that I know every fact and everything about, the sun. It's about, I know how to examine the information and say, oh, hey, like this person might know it better, or and then is that reasonable, right? If they suddenly told me like, well, the moon's made out of, blah blah blah, I'm like, no, that's not right. I need to know, approximately what it is. But again, I don't necessarily know everything.
Yeah, and we specialize, right? Like as a scientist, you're specializing in heliophysics, and then we have people that specialize in planetary science or lunar science, and so it makes sense. I'm just messing with you. I'm just joshing with you.
Okay.
All right. Scott is asking, why does the moon change locations on screen when we see different time and date telescope feeds?
I think that is just a orientation of the telescopes. Because it might drift to like one side of the feed, one side of the picture or the other. And that's just alignment of the telescope. It takes a lot of setup to learn how to do this type of imagery as well. They're doing amazing at time and date. And they have done amazing for forever. But it takes a lot to get it to look this good. That's actually why I tell people your first eclipse, let the experts do it and just experience it. Because it's a great hobby to figure out how to do this or and how to line up the telescopes and do that, but it's a lot of work. And so maybe the first one, just experience it.
Yeah. I am looking forward to my first one. No cameras, no anything. It's just going to be me and watching nature do its thing. I love it. Okay, we have another kind of moon question for you. Aaron Equus on Twitch asks, so there's a lot of talk about the sun during the solar eclipse, of course. Are there any unique properties of the moon that are only visible during an eclipse that you know of?
That's a good question. The moon is rocky and not quite as smooth and kind of, it looks like a beautiful ball when it's full from the earth, but it actually has craters and valleys, so peaks and valleys, and you can see some of those. And that's actually what we'll see coming up here with the Bailey's beads is actually the last bits of the fact that it's not perfectly smooth. We're seeing little bits of sunlight still kind of escape until it completely covers the face of the sun. So as you're seeing in the feed or in the image right now, is you'll see those little beads, and those are actually telling us about the peaks and valleys on the moon.
Excellent. Okay, so we have a really good question from Heather Jarvis, and the question is it happening or almost over, and what time is totality? So what are we seeing here?
It is happening. So we have most of the disk covered right now. And so the upper left is the moon. That dark circle or semicircle is cutting out the little crescent sun that we're seeing. And the prominence is still there on the left-hand side. And so what is happening, and I think we're around 10 minutes, 15 minutes from totality. So then we'll see those Bailey beads that we just talked about. Diamond ring is the last one that comes out because it looks like there's a great big diamond on the sun. And then that'll go off, and then we will see totality. And that's where we would take off our eclipse glasses if we were there, and kind of bask in seeing the corona and experiencing the whole thing. And then after that minute's over, we would put on our glasses, and we will then go backwards and see the diamond ring, the Baily's beads, and then back to this partial eclipse.
So you kind of talked about this before, but Kaz on YouTube is asking, is it possible to never have an eclipse during a year?
Since they happen about every 18 months, it would be possible to not have one during a year.
Yeah. And I'm assuming that just meant solar eclipses
Yes.
that Kaz was asking about. All right. Very Pezzy on YouTube asks, is it possible to see the eclipse using a telescope from home?
That's a good question. So really, you need to be in the path of totality, or a path of path of the eclipse in general. So either a partial eclipse or a total eclipse. So it somewhat depends on where you live. Again, if you're in the US, you will see one in 2024 or 2023. So hopefully, yes. And then if somewhere else, we can find resources online to see when the next eclipse is going to be in your area.
Excellent. Our folks working in the background, you guys are geniuses. So for the question asking if lunar or solar eclipses are more common, we have a little bit more information for you. Lunar eclipses and solar eclipses are about equally common. They usually happen in pairs. So a lunar eclipse will usually happen 2 weeks before or 2 weeks after a solar eclipse. However, more of the Earth will be able to see a total lunar eclipse than a total solar eclipse. So they may seem more common in one given location. So thanks for that.
Yeah, that's great, because I think that's what I was thinking, is it's more common to be like, oh yeah, you can see a lunar eclipse, than a solar eclipse is a much more narrow path because the moon's smaller. Yes. Okay, great.
Excellent. Yeah, that was a really good answer. Thanks for the clarity on that. Willie D on YouTube asks, what kind of gravitational pull does this kind of event do to the life on Earth with celestial body alignments? Are there animals and plants that react to this event? Thanks.
Okay. Well, that's great. So animals and plants do respond to this event in general. Again, from what I understand, is much more from the actual visual or sensory of the darkness that they sense, rather than maybe direct gravitational pull. But maybe that's a study that you should propose. That what's the effect on animals for gravity? I think it's my sense is that it's more from a visual sense than a gravitational sense, that there's an effect on animals.
Gotcha. Okay, that makes sense. Susan Stalker asks, do solar flares interfere with technology here on Earth? And is there cause for concern? That's a really good one.
That's a really good question. Yes, solar flares do potentially cause issues with our technology here on Earth and all of our space assets. And so we are, at NASA, as well as in partnership with many different folks in commercial, as well as all with government, NOAA, NASA, NSF, all of the folks are working on this. It's a term called space weather. It's the effect that the sun has on the Earth and the entire environment, the entire interplanetary environment. So we are looking to mitigate those things, things like potential power outages or inducing huge currents in the Earth, things like that. We are looking into that and making sure that those solar flares don't get the best of our technology.
Yeah, and that's a big part of the heliophysics big year, right? So like at NASA, the heliophysics has a fleet of missions that are working to study the phenomena of space weather and the sun's impact, throughout our universe. Particularly, do you want to talk a little bit about Parker Solar Probe, which has touched the sun?
Yes, so Parker Solar Probe, a little near and dear to my heart, is the spacecraft that has gone in and actually touched this corona that we have seen. And it is a spacecraft that goes in and looks at the particles coming off of the sun, both through imaging as well as scooping some up in some of the detectors, and studying the magnetic fields of the sun. So that mission has successfully touched that corona and is continuing to study it and to, again, help us understand that space weather.
Excellent. Yeah. Looking at this, we're getting closer. We're getting closer. I'm so excited. It's happening.
I know. It looks like a great big smile. It's a great big smile right now. The sun's kind of smiling.
Okay, back to the question. So we have two related questions. David Gray on YouTube asks, what is the expected temperature drop during a total solar eclipse? And Raymond DeMay on YouTube is asking, is there a measurable temperature drop? So are people going to be able to feel a difference?
You can definitely feel a difference. It can be a couple degrees to tens of degrees. So like, for instance, my last solar eclipse, I had to put on a down jacket. I was in a short sleeved polo and had to put on a down jacket. I'm also cold, so, but it was definitely noticeable that folks were putting on jackets. And so, it is a measurable temperature, and that is part of a citizen science project, is to actually measure the temperature as you're going, as this is going along, especially with, animal reactions, is to figure out what they're actually reacting to.
Here's a really good one, kind of based on the something you said earlier. Forrest Walker 111 on YouTube asks, if a flare were to happen right now, would it be visible? Would we be able to see it during this during the eclipse that we're watching?
So if we were to be able to see a visible light flare when the eclipse was happening, that would be a big event. So that would be related to, so for instance, one of the most powerful events that we kind of have recorded is the 1859 Carrington event, where telegraph lines at the times caught on fire and were able to work without batteries for days based on the energy that was imparted from that flare to the Earth.
Wow.
So if we were to see an actual flare in the visible light, that is what was seen associated with that as well. So that's a big storm. So it'd be super cool, yet at the same time, it would be very interesting to see what would go on. Most of the flares we look at right now are done in the extreme ultraviolet, and that is how we normally see them, which is unfortunately something we can't see with our own eyes.
So one thing you've mentioned a couple of times, and people are asking questions about it, is a prominence. So what is a prominence? Is that a flare that we are seeing on the left side of the sun, or what is a prominence? What are we seeing?
Good question. Yeah. So a prominence is a protrusion of some of the gas of the sun along a magnetic field line. So the sun is a magnetic star, and the background image you're actually seeing has kind of those twisty magnetic fields and the gas or the plasma following those. And that's what a prominence is. It's a sticking out of one of those magnetic fields, and then the gas and plasma sticking with that magnetic field line and protruding. And so it can be a precursor to a flare. It could be part of a coronal mass ejection. It could be ejected from the sun as a mass that comes through the solar system. It's equivalent to 80 million school buses in mass hurling at us at 1 million miles an hour when a coronal mass ejection goes off, and a prominence can be part of that. So that's why it's just interesting. It is an active part, and there were some active regions rotating off the disk, and I think it was just about that area. So I was interested to see what we would see once we got to totality. So, and we're getting close. We're getting really close now.
I know, it's so close. All right. Shariah on Twitter asks, are we able to see sunspots during a solar eclipse?
We are actually able to see sunspots most days, so which is great. So when the sun leaves again, when the moon leaves again, and we can see the sun, there were some darker features on the sun, little spots, and so you are able to see sunspots in the visible light. And even with your eclipse glasses, you should be able to see, go out and see when there are large sunspots on the sun.
Okay, we've got another question on safety. Dobby330 on Twitter asks, is there any part during an eclipse that is safe to directly look at the sun without glasses?
Yes, and we are almost there. So when that moon is totally covering the disk of the sun, it is safe to take off your glasses and to see the solar corona. Now, again, we have to really make sure that we're on the path and we know that there is totality and that we can't see anything. And one good test is if you have your glasses on and you're looking at the sun and there is nothing coming through those glasses, that is when you can take it, then you could take it off. If you see the littlest light in that glasses, because they're really dark, you're not going to see normal lights. But you will see the sun through them. But when you don't, that's a sign that you can take off your glasses.
We're close. Let's do another one. Gabrielle Codina on YouTube asks, is it possible to encounter an eclipse and northern lights at the same time?
Ooh, that would be like a really great thing to do. So we would just need to have an eclipse over. You normally see aurora in the northern or most southern latitudes, northern or southern lights. So if we were to have an eclipse that passed through, say, Alaska or Greenland or Iceland, you might be able to catch both the eclipse and the aurora.
We're close. All right, let's see if we can squeeze another one in. This is a really good one. Shades McCoy on Twitch is asking about, have we discovered any planets that experience total eclipses or eclipses like Earth does? It feels pretty rare.
It does. And actually, my colleague Michael said this the other day, that realized that this is the only place in the solar system that this happens. Like, how special is that we get to be here and have a moon that blocks out the sun? Like, it's not something that's done every day or any place else that we know of. So this is very, very amazing. And we do use eclipse-like things to measure, to actually find exoplanets or other planets around other stars, because as they pass by, they weaken the light from the star, and we use that to actually sense that they're there. So we use an eclipse-like scenario, but we don't know of really any other eclipses.
Interesting. All right. So it looks like we're getting like really close to totality. Let's take a closer look at the feeds coming in from Australia. Kelly, do you want to tell us what we're looking at and kind of talk us through this?
Yes, definitely. Awesome. So we're getting really close. So the dark upper left-hand side, you see the moon, and then that little sliver is still the sun, and then the prominence, again, that little stick out of magnetic field and plasma is at the left. It looks like a little jet maybe coming off of the sun. And as we're getting closer, again, we're trying to see those Bailey's beads, which tells us a little bit of the surface of the moon and how it's peaks and valleys. It's not a perfect polished sphere. It has a history, and we're going to see that shown through the Bailey's beads, and then eventually just go to one diamond ring. And then we will go into totality. So again, we're getting real close, about 2 minutes.
Wow. And you can still see the prominence.
You can see the prominence more and more. And I'm actually seeing a little bit of something also almost directly across from it. There's a kind of a band of activity that happens as these things form, and so it's kind of in that same band. So I think of it as almost directly horizontal, but we'll see as we get closer if that comes out at all, and can see a little bit better. No, we're really getting dark, and so if we're in Australia, it's probably again dropped in temperature a little on that beach that we saw Henry was at, and again, any animals might just start to think that it's nighttime. The air or the light will actually get really it just feels eerie, and it's like your brain knows that something's just not quite right. Like I'm not sure about this. Where did the sun go, and why is it in kind of a different color? And it's getting really, really close, and and it's exciting to experience this live with y'all.
Yeah. And we're still glasses on, right?
We are still glasses on at this point in time. You will still be able to see that thin. Yeah. And so we're almost there. Oh, and now it has gone dark. Oh, that's still too bright. We probably should still have our glasses on. But those are the Bailey's beads. And we are going towards those beads, diamond ring. And there we go. There is your total solar eclipse. So glasses off at this point in time, experiencing this beautiful corona. So that prominence is out there. You see that. You also see on the other side, almost like helmets or triangular shaped flows. So the solar wind is flowing out. And so we're really witnessing that corona there. And as they adjust things, wow, there's just all sorts of structure. So it's not a simple thing, right? It's a very complicated, dynamic, always churning, always moving, always evolving. And you see so much structure out. And this is what hopefully that kite is recording right now, is all of these different prominences, and you almost see loops sometimes. And then again, things that look like they flow out of the picture. That's the solar wind, and that's what connects with our planet. And now we're actually getting the Bailey's beads back. So this would be glasses on. Again, it was a very short but amazing experience. And again, we're going to have around 4.5 minutes in places in the U.S. In 2024, but that was beautiful. So yeah, so the Bailey's beads are coming back. We're coming back now into what is more of some more beads coming back. And you can still see a little bit of the corona, but again, we would have our glasses on at this point in time because this is the safest, this or your glasses are the safest way to view the solar eclipse.
Wow, this is just phenomenal. Absolutely spectacular.
It is amazing.
Wow. How many eclipses have you seen?
So I have seen 2 total eclipses in person.
Wow.
Yeah, and each one this is magical, and there is just something about experiencing it that is surreal. Oh, wow. Yeah, so there's the prominence and all of the other type of mass that's just kind of hanging out there and playing on the loops, the magnetic loops of the sun. And yeah, it's beautiful.
That is absolutely phenomenal.
Yes. And this activity kind of picks up as we go towards solar max. And so with predictions right now, solar max is somewhere between 2024 and 2025. So we could have a very active and really structured and a lot of different things on the sun as we have our total eclipse in 24 and our annular eclipse in 23.
So can you talk us through that a little bit? So you're talking about solar max. So the sun has cycles, the solar cycles. What's the difference, and what does solar max mean? And
Yes. Yeah. So the sun has cycles in its magnetic energy. What happens is basically the magnetic fields get twisted, and then suddenly they have to just break and relax. And so the minimum is when they're relaxed, and the maximum is as they are getting more and more twisted and more energy to blow off the steam through coronal mass ejections. Those, again, 80 million school buses racing towards us at millions of miles an hour, or the solar flares or the energetic particles that the sun gives off. And so this cycle, that going from that really relaxed magnetic field to really tense, it takes 11 years to complete. So you end up going around 5 to 6 years to a maximum, and then back to a minimum, and back to a maximum again. And we're headed towards a maximum in 2024, 2025. And so that's, again, we're going to have a lot more activity, more flares, more coronal mass ejections, and those energetic particles.
Okay, so let's keep watching as we take a few more questions. Here's a really good one. Aaron Polito on YouTube asks, what useful data does NASA get and what do they do with it from observing eclipses?
That's a great question. And we take all sorts of different data during eclipses. There will be an announcement soon of things that we're specifically doing for the 24. But for instance, for the kite that is flying in Australia today, there will be a spectrometer. So there'll be data from that, and that will all have to go into an archive for NASA and to make sure that's open and available to folks. So any of the things, any of the data that is collected from a NASA source will then be available to use for anyone shortly after it is collected.
Oh, wow. Okay. And I've heard that eclipses provide kind of like a perfect scientific environment for taking measurements if we're trying to do certain types of measurements. Why is that?
It is a really great environment in terms of we don't normally get to turn off the sun on things regularly. We don't get to snap our fingers and just turn night to day or day to night. So for instance, in 23 and 24, we will launch rockets into the eclipse and be able to study our ionosphere, which is a layer of our atmosphere where a lot of our communication signals go through. And if that gets disturbed from a day to night transition, we get to be able to study it very easily during an eclipse, because that's again like a very specific time where we know it's going to happen and we know it's and we can study those effects, and that's a very known time to do these things. So it's great to have as an experimental laboratory for us.
Yeah, that's so cool. And I love that. Like we don't get to turn off the sun. That is so true. Okay, so an Arctic Floof on YouTube asks, once totality has happened, how long will it take for the sun and the moon to be back to their normal, and I'm using air quotes, positions?
Right. So this will take about another hour or two to move the moon off the sun, or the what will then be look like two separate things again.
Okay. Road Call Life on Twitter is asking, does totality last longer in the middle of the path of totality than along the edge of the path of totality, or is it the same everywhere? So like, how does that work? How does
that's a great question.
Yeah.
And so in the very middle of the track is where it will be longest, and then it will be shortest on the outside of the track. So when we were looking at the map earlier, the very center is where you're going to get the longest totality, the very center line. And then as it goes out, you will get kind of less and less time in totality. And then once you're out of the track completely, that's when you get a partial eclipse, like a 90% or 99% eclipse.
Excellent. Well, Kelly, that's all the time we have. Thank you so much for joining us today.
My pleasure. Anytime. I'll watch an eclipse anytime with you, Denise.
It's a date. All right. You can keep watching the remainder of the solar eclipse right here on NASA TV or wherever you're watching the stream from today. If you want to learn more about eclipses, visit solarsystem.nasa.gov/eclipses. And you can also follow NASA Sun on Facebook and Twitter to stay updated on the upcoming eclipse events and the latest sun science. Thank you all so much for joining us. We'll see you next time.
The Heliophysics Big Year is a global celebration of solar science and the sun's influence on Earth and throughout the solar system, and we want you to be a part of it. We challenge you to participate in as many sun science activities as possible, beginning with the annular eclipse in 2023 and ending with Parker Solar Probe's closest approach to the sun in December 2024. Space is increasingly part of the human domain. By studying the sun's influence in space and its interactions with planets, we learn how to better protect astronauts and robotic missions from space weather, and to develop technology that protects the very infrastructure we rely on here on Earth, such as power grids and GPS signals. NASA's Heliophysics division studies the sun's influence on everything in our solar system, from the very core of the sun to the very edge where the sun's atmosphere meets interstellar space. We have 20 heliophysics missions that are operational and 14 more under development. The Heliophysics Big Year will highlight the work that we're doing to understand our star and to mitigate the effects of space weather. The Big Year is a concept that originated with citizen scientists in the bird-watching community. During their big year, birders attempt to observe and study as many species as possible during a calendar year, and we are challenging you to do the same with our sun. During the Heliophysics Big Year, you will have the opportunity to participate in many solar science events, like watching solar eclipses, experiencing an aurora, participating in citizen science projects, and lots of other fun sun-related activities. So please be sure to look out for opportunities to be part of our Heliophysics Big Year.
Imagine you are on the moon. Your job for the next 8 hours will be exploring, traversing up and down lunar hills, sampling rocks, and setting up equipment. Temperatures can reach a blistering 250 degrees Fahrenheit. Luckily, you have a portable life support system, a backpack that provides oxygen, water,
You're watching live coverage of the NASA SpaceX Crew 5 mission as they return to Earth. Dragon Endurance departed the International Space Station at 11:20 p.m. Pacific last night with NASA astronauts Nicole Mann and Josh Cassada, JAXA astronaut Koichi Wakata, and Roscosmos cosmonaut Anna Kikina. Currently, they're on their way to the targeted splashdown site off the coast of Tampa, Florida. My name is Kate Tice, and I'm the Quality Systems Engineering Manager here at SpaceX. And joining me today from NASA Communications is Leah Cheshire.
Thanks, Kate. It's always great to be here. And of course, another exciting day bringing a crew back from the International Space Station. So upon departing the station, Dragon underwent a sequence of departure burns. Since then, the crew had a rest period and has since kicked off preparations for re-entry. Things are sounding pretty good so far. So in this next phase of the mission is when things really ramp up and happen pretty quickly. Dragon has a series of steps to complete before returning Crew 5 back to Earth.
First, Dragon will maneuver to the correct attitude and jettison its trunk, which is the cylindrical, unpressurized part of the spacecraft. The trunk is currently connected to the aft or the bottom section of the Dragon capsule, where the heat shield is located. So in order to expose that heat shield and get the vehicle ready for atmospheric re-entry, we'll jettison that trunk.
And just a quick look right now inside Crew Dragon with our Commander Nicole Mann on the left and pilot Josh Cassada on the right. After we jettison that trunk, we're looking for that to come up not too long from now, but from there the spacecraft will use its forward thrusters to perform the deorbit burn, which will put Dragon on a trajectory to return to Earth. The burn will last just over 11 minutes once it starts, and it uses the Draco thrusters on Dragon. These are the four located on the forward bulkhead primarily, and it's executed at the apogee or the highest point of Dragon's current orbit around Earth. This will alter Dragon's path to ultimately line it up to re-enter Earth's atmosphere and splash down off the coast of Tampa, Florida.
That's right, and we're actually looking at that trunk separation to happen in about 3 minutes.
Deorbit sequence start.
And we've heard good calls from the core here in Mission Control Hawthorne. That's the Mission Control room you see on your screen. To the crew, another good interior shot. Down in the bottom left-hand corner, that's Anna Kikina, the Roscosmos cosmonaut. That has flown on Crew 5. And then we are also on the other side of the spacecraft. We didn't get a good look at him, but it's Koichi Wakata, the JAXA astronaut that has joined us as well. So again, good calls. We've heard good confirmation of suit leak checks up until this point. As you can see, the astronauts are in their suits and seats after they had some time to rest and relax over the past, what's it been, 18-ish hours since they undocked yesterday.
Yeah. Like everything that occurs on the International Space Station, everything is scheduled, it's choreographed, including that sleep period, that crew rest period, where basically the crew got to clock off duty and rest, relax, enjoy the view, I would imagine.
Yeah, absolutely.
So at this point in time, like we mentioned, we are coming up to the separation of the claw, which is the mechanism that holds that trunk, that unpressurized section of the Dragon capsule onto the pressurized section. So we're about a minute away from that claw separation, and then trunk separation will occur in about a minute and a half. So yeah, that trunk, like we said before, is the unpressurized section. That's where we can store cargo that is able to be exposed to the vacuum of space. And of course, the astronauts are in the pressurized section. But that heat shield is located at the bottom of the pressurized section. So it's currently being covered up by that trunk. So we'll separate the trunk to expose that heat shield.
Another important thing to note is when we do claw separation, we're separating those umbilicals that connect the trunk to the pressurized section or the actual Dragon capsule where the astronauts are. So the solar cells that are wrapped around the trunk, those will of course be detached. And once we dispose of the trunk, Dragon itself will be on internal battery power.
Yeah, so pretty exciting. All of this, as you mentioned, Leah, it's been 18 hours of progress. But at this point in time, to prepare for the upcoming events, right now the Dragon spacecraft is doing a couple of things autonomously, meaning it's doing it on its own. It's isolating the thermal control system fluid loops from the radiator. This system is what will help keep the internal temperature of Dragon very comfortable for Nicole, Josh, Koichi, and Anna during that re-entry phase. Dragon is also initiating separation of the claw mechanism. Like I said, that's coming up in about 10 seconds or so. And that will terminate, like Leah just said, that data, the power, and the fluid connections between the capsule and the trunk. So we're standing by to listen for the call out for trunk separation.
And I got one update that we are in the proper attitude for that trunk separation. So
Awesome.
Just one more of those checks that we were standing by to hear. Again, we are just in a waiting game until we have that claw and trunk separation. But that
nominal trunk jettison.
All right, there's that call. Great news.
right on time.
Dragon stuff.
So as you can hear, that, like we mentioned, is the core calling out to the crew. They report that they copy because they're able to keep track of it on those crew displays that we could see over their shoulders. So again, the claw and trunk just separated. The claw is where those umbilicals for power and telemetry are from the trunk, and its solar arrays connect to the capsule. So now that they've disconnected, again, Dragon is exclusively on battery power. And we just additionally got that confirmation of successful trunk jettison as well, coming right on time at about 5:06 p.m. Pacific. So with that trunk separation, telemetry is looking good. The nitrox system is primed for cabin and suit cooling, and the heat shield is now exposed. The trunk is no longer needed. That is setting us up for our deorbit burn here coming up. It's scheduled to start at 5:11 p.m. Pacific time. Again, we anticipate that will last about 11 minutes.
Yeah, that burn is an important one. That is what commits the crew to that location. Like we said, we're setting up for a landing off the coast of Tampa, Florida. And it's that deorbit burn that is the final burn that Dragon performs to really re-enter the Earth's atmosphere. Now, up next, we have the final steps that Dragon will perform prior to re-entry, the slew or maneuver to deorbit burn attitude and the deorbit burn itself. Leah, you did indicate that that attitude was correct and that we're going to start that deorbit burn soon. That will be the last time that the forward Dracos, which are the four thrusters located on top of the vehicle near the nose cone, it's the last time that those will ignite. The deorbit burn will place Dragon on a precise trajectory to return to the splashdown zone off the coast of Florida. And like Leah said, it'll last about 11 minutes once it begins.
And again, we're tracking that to come around 5:11 p.m. Pacific, so 8:11 p.m. Eastern time. And we are actually under an hour now until our anticipated splashdown time. So when we say things are happening fast, they are happening pretty fast. But again, this is an autonomous flight like we've seen with Dragon in the past. And our 4 crew members are riding comfortably, it appears. Their visors are still up. Once we get closer to that deorbit burn, we anticipate to hear a call from the core to the crew to go ahead and lower their visors just as a precautionary measure ahead of that major burn.
That's right. And the crew has already completed the required suit leak checks. It's basically when they pull all the zippers up, close the visor into the locked position, and the Dragon spacecraft pressurizes, or basically flows a little bit of that air into the suits and holds it at a certain pressure for a certain amount of time, usually a couple minutes, just to make sure that those suits are basically all the zippers are in place, and that seal with the visor is functional, and really just making sure that the spacesuit provides its own individual environment for the crew member during the more dynamic events of today's procedures. So like Leah just said, we can see that those visors are still up, but we know that they've already completed the suit leak checks, had 4 good leak checks there. This is also a great shot because you can see the tablet on Commander Nicole Mann's leg. So those are the tablets that are used for monitoring Dragon's progress and the different statuses and states that the vehicle is in. It's also what they use to log the consumables during flight. So we talked before about that period of time where the crew is off duty. They can do whatever they want to do. And as you can imagine, staying hydrated is important, and they use those tablets to track how much water they drank and out of which water bottle it was. So it's just helping to make sure that everything is accounted for. Like we said, we're coming up to the deorbit burn. We're about 5 seconds away from that burn start.
Now again, this is going to be an 11-minute burn, approximately. Just over 11 minutes. It's pretty large. We've got to slow the astronauts down from orbital velocity at 17,500 miles per hour and put them on that track to Tampa, Florida, and that splashdown. If you look, you can see the windows near Josh Cassida's feet. Actually, it's in the background, but it's bright. It's clearly they're in an orbital daylight. But when you're traveling at orbital velocity, 17,500 miles per hour, you see a sunrise and a sunset every 45 minutes. And if you look on their crew displays, it looks like you can see some of the thrusters are firing. So sounds like the deorbit burn is underway. Again, started right on time at 5:11 p.m. Pacific, targeting about 11 minutes for that burn.
We're looking at about 10 minutes and 20 seconds remaining in that deorbit burn.
Within just the last 10 minutes, Dragon jettisoned its trunk. It initiated that deorbit burn about 2 minutes ago now. So for these operations, NASA and SpaceX closely coordinate with the United States Coast Guard and have established a safety zone to ensure public safety, safety of those involved and in the recovery operations, as well as, of course, our crew on board the returning spacecraft. So multiple notices are issued to the mariners in advance and during recovery operations. And Coast Guard patrol boats are deployed to discourage boaters from entering the splashdown zones. So we want to take a moment to stress to the public the need to respect this safety zone. Recovering a spacecraft from the water is a hazardous operation. And so any other boats interfering in this process can increase risk to the astronauts in the capsule, those teams working to recover them from the water, and of course, even the safety of any public boaters. So for the safety of the crew and yours, we recommend tuning in here. Just sit back and watch. We're going to give you the best views of our astronauts on their way home.
Like I mentioned earlier, this deorbit burn is the last time those 4 forward Draco thrusters will fire. Dragon Endurance has not yet entered the Earth's atmosphere. This deorbit burn is what will line the vehicle up and put it on its final trajectory to the landing site off the coast of Tampa, Florida. As you can see on your screen there right now, Nicole, Josh, Koichi, and Anna are using their screens to keep tabs on that burn duration, the Draco thruster firings, which you can see lighting up on those displays in front of them, the trajectory details like the entry angle, capsule perigee, and how much distance remaining until deorbit burn termination. So in that center screen, you can actually see their trajectory, their planned trajectory there. Dragon is flying itself, so all of the crew, all that the crew has to do is stay strapped in their seats and keep tabs on things, which I know for me personally, I love looking out windows when I'm traveling, especially in airplanes. And so I imagine if I were flying, this part would be really hard for me because I just want to get out of my seat and look out the window.
Those last few space views, I'm with you. I'm always a window seat girl.
Now, with Nicole, Josh, Koichi, and Anna ready to deorbit and splash down back on planet Earth, they'll be heading to one of 7 targeted sites supported by SpaceX and NASA. All of these sites are located off the coast of Florida, either in the Gulf of Mexico or the Atlantic Ocean. Spreading the supported sites across multiple locations actually helps to maximize the return opportunities for this mission and future crews, lowering the chance that we'll have to wave off due to bad weather. So pretty helpful.
Yeah, absolutely. So yesterday, NASA and SpaceX together selected primary and alternate splashdown locations. Obviously, our primary, as we've discussed, is off the coast of Tampa, Florida, and the alternate is Daytona. This selection process works with a lot of different variables, including the space station's orbital trajectory, the landing sites available, and favorable weather, as you mentioned. Of course, how much free flight capability Dragon has for the trip home, and the sleep schedule for those returning crew members.
We'll start with calculating daily return options based off of the space station's current orbit and Dragon's capabilities to maneuver and line up for re-entry. The time from undock to landing at the primary site can vary from less than 6 hours to more than 39. Getting home the quickest comes with some obvious benefits, but we always have to make sure that the crew is properly rested for dynamic operations, preventing us from scheduling 20-plus hour days for them. Trajectory and ballistics experts provide the daily opportunities that would line up Dragon with the 7 landing zones and split them into what we call ascending and descending opportunities.
Dragon uses its Draco thrusters after leaving station to execute a series of altitude-lowering maneuvers until line up with this selected primary site, but it can also change to different alternate sites while in free flight if sudden weather moves in that we need to avoid. That's something we're currently or constantly looking at as weather, so we make the final call to proceed about 2.5 hours before the crew undocks. For the Crew 5 return, as always, we look at a number of weather items. Some of those more obvious ones are no rain or chance of lightning in the recovery zone, both for the safety of the crew in the capsule and the recovery teams on the water. We're also looking for wind speeds less than 15 feet per second, or about 10 miles per hour, and relatively calm seas so we can safely execute recovery operations, which includes landing a helicopter on the recovery ship to fly Nicole, Josh, Koichi, and Anna back to Florida. Now, I have heard the weather described in 4 different ways for this Tampa site. I've heard go, very go, home run, and stupendous. So it sounds like they have a pretty nice landing site waiting for them today.
I think one time we also got super go.
Oh, wow. That's another level. So once Dragon began flying free yesterday, there were a number of additional checkpoints to either proceed toward the primary site, head to the alternate, or select a new zone based on real-time weather data. These checks happened all the way up until we are in the final hours before the deorbit burn, which started about 6 minutes ago. That's this last burn in the trip home, and it commits the Dragon capsule to re-entering the Earth's atmosphere.
Before we go any further, let's go ahead and take a minute to meet our crew.
First up is Nicole Mann on the left side of the screen there. She's the California native who holds a Master of Science in Mechanical Engineering and is a colonel in the Marine Corps. She was an FA-18 Hornet and Super Hornet test pilot and deployed twice aboard aircraft carriers in support of combat operations in Iraq and Afghanistan. Nicole was selected by NASA in June 2013 and in the years that followed led the astronaut corps in the development of hardware in the Artemis program. She is the Dragon commander for Crew 5, which was her first space flight. She's right there in the foreground of the shot monitoring this deorbit burn, and she is also the first Native American woman to stay on the International Space Station.
Sitting next to Nicole is Josh Cassida, who grew up in Bear Lake, Minnesota. The physicist and U.S. Navy test pilot flew 23 combat missions and later became an instructor at the U.S. Naval Test Pilot School, which is a common path military officers to take to join NASA. Cassida is one of more than 100 graduates who became astronauts going back to the Mercury program. On Earth, he served as capsule commander in mission control, but for his first space flight on Crew 5, he has served as pilot on Dragon.
In the role of mission specialist, you can't see him here. He's to the left of Nicole. That's Japanese astronaut Koichi Wakata. Koichi has a doctorate in aerospace engineering and in 1996 became the first Japanese mission specialist aboard the Space Shuttle Endeavour for STS-72. In addition to his current mission, Koichi flew 4 Space Shuttle missions, a Roscosmos Soyuz, and was on a long-duration stay aboard the International Space Station. And just on March 6th, just a few days ago, Koichi reached his 500th day in space.
Wow, that's pretty incredible. The second mission specialist is Roscosmos cosmonaut Anna Kikina. She graduated from the this is a tough one, Novosibirsk State Academy of Water Transport in 2006. In 2012, Anna officially became a candidate for the position of test cosmonaut. Crew 5 was Anna's first flight into space as part of the resumption of integrated crews on U.S. cruise spacecraft and the Soyuz with the Russian State Space Corporation, Roscosmos.
Now we are still in that deorbit burn. Those crew members now about 42 minutes away from that targeted splashdown time of 9:02 p.m. Eastern Time. It looks like we have about 2 minutes left, maybe a minute and a half in that deorbit burn, but things are going well so far. All of those 4 Draco engines firing for the last time before closing that nose cone and preparing the capsule for reentry.
There on your screens, you can see the crew is continuing to monitor Dragon's progress in this deorbit burn. We have about a minute and a half, 1 minute and 31 seconds to be exact, remaining in this burn. As you can see with those displays, there's a small set of physical buttons that the crew can use for emergency situations. And then the displays are touchscreen, which has more features that they can use in flight, in addition to the tablets that are on their legs. You can see Nicole's there on her left leg. We can also see a good shot of the control panel for the seats themselves. That's where the mic volume and the push-to-talk button is also located for the crew to use. And I believe that's also where the crew cabin light button is located. So just like an airplane, everybody has their own personal window, or excuse me, personal light that they can use.
Reading light.
Yeah, to read, exactly. There's also USB ports in the Dragon capsule as well.
That's convenient.
Yeah, not on the chairs. It's kind of like above their heads, so they can't really reach them while in flight, but certainly useful during the opportunities where they don't have to be in their seats and can charge up those tablets that they use.
Now, continuing to monitor, again, we are in the deorbit burn and should be wrapping up here very shortly. Crew members just monitoring as this is a completely autonomous flight.
10 seconds remaining in this deorbit burn. That deorbit burn is...
Deorbit burn complete. Performance nominal. Nose cone closure initiated.
Dragon copy.
Just what we wanted to hear. Deorbit burn is complete. Nominal is always the word we're looking for. And so with that complete, next up is closure of the nose cone, since we won't be using those Draco thrusters anymore.
That's right. That nose cone is what protects those Draco thrusters, as well as that forward hatch, which is the hatch that the crew, of course, used to dock to the space station and get in and out of Dragon while it was docked on station. That side hatch is what they will be using, or the side hatch, which is on the side of Dragon, is what they will be using to get out of the capsule after splashdown, but not that forward hatch, which is what is being covered up now what will be covered up as we step into nose cone closure.
Wow.
And there we can see a live view of that nose cone closing on Dragon Endurance.
So in the Dragon is currently inhibiting those forward bulkhead Draco thrusters that we just used to complete the deorbit burn. Those are inhibited now, I should say, meaning that it was safe to latch the nose cone shut. And the vehicle has initiated the nitrox suit purge. This will help keep Nicole, Josh, Koichi, and Anna cool and comfortable during re-entry, which is coming up in about 20 minutes. At this point, like we saw, the nose cone is closing, protecting the forward hatch for reentry. So Nicole, Josh, Koichi, and Anna are using their screens to continue monitoring the locking of the nose cone, which is done by a set of hooks.
That's exactly right. Now we have a live view there of Mission Control Hawthorne, actually located just to the side of Leah and I. That is where the calls are coming from that we hear to the crew, coming from SpaceX Core Mike Blasco. Another view there of that nose cone closing. There's about another minute and 14 seconds remaining in the nose cone close. But yeah, those calls that we hear to the crew and basically communicating status of what's happening or what has completed, that comes from that room that you see there on your screen.
We're standing by for the confirmation of nose cone closure. We are now about 18 hours since undock yesterday. So we've mentioned that the crew has had time to rest, relax, maybe eat a little bit, take a nap. But right now are monitoring the continuation of nose cone closure, just waiting on that call out to the crew.
About 30 seconds remaining now to nose cone close. As we said before, since we won't be using the 4 forward Draco thrusters, and obviously the hatch is sealed and shut, we are able to close that nose cone. It's an important step because ultimately this is the, now that the trunk has been separated, this is the last major physical change that Dragon will undergo prior to deorbit burn.
Dragon that the Crew 5 crew members are flying on today is named Endurance. It was dubbed that by the Crew 3 crew in honor of the endurance shown by the NASA and SpaceX teams as they were building and training, or building the spacecraft and training the crew through the pandemic. So I thought that was a really nice way to honor both the teams.
Very fitting for sure. So we're standing by for the call out to confirm that the nose cone has been closed. Again, this is the last major physical change that Dragon undergoes prior to that deorbit burn, or excuse me, prior to re-entering the Earth's atmosphere. They've already completed the deorbit burn itself.
Yes.
So this nose cone closure is an important, one of the last steps prior to that re-entry.
That deorbit burn really commits us to returning to Earth. There's not really any waving off after that happens.
And as we mentioned before, we are targeting a splashdown off the coast of Tampa, Florida.
And a look here at both teams monitoring the mission. Over on the left is Mission Control in Hawthorne, and on the right is Mission Control at NASA's Johnson Space Center in Houston, Texas. Home sweet home. They were in joint operations while Dragon was docked to the International Space Station and until the spacecraft exited the approach ellipsoid. So now the teams are continuing to watch the re-entry of the spacecraft and prepare to welcome the astronauts home, but in a monitoring mode now, since we are obviously quite a ways away from the International Space Station itself. And as for the crew on the International Space Station, they are in a sleep period right now, but they do have the opportunity to watch these broadcasts and watch their friends arrive back on Earth. So hopefully if they're watching, they still take some time to get a little shut-eye later tonight.
So at this point in time, the nose cone is closed. We're just waiting for that to be called out to the crew. From the SpaceX core, next up will be to initiate that nitrox suit purge. Again, that just helps to keep the crew super comfortable during that re-entry period.
And then coming up a little bit later tonight, around 5:50 p.m. Pacific time, that's when the entry of the spacecraft will begin. And during that time, we anticipate to lose communication with the spacecraft as the plasma is building up around it. It is traveling through the atmosphere. Eventually, we will regain that signal and communication with the crew members. But of course, Dragon knows exactly what it's doing that entire way home. They are just monitoring and getting closer and closer to splashdown. Again, targeting splashdown for 9:02 p.m. Eastern Time, 6:02 p.m. Pacific, off the coast of Tampa, Florida. Nose cone closure continues. It looks like the first set of hooks is closed and the second set is closing as we speak. For our 4 crew members on Crew 5, for 3 of them, this was their first space flight. So Nicole Mann, Josh Cassada, and Anna Kikina are all coming home with 157 days in space. As we mentioned earlier, Koichi Wakata this is his 5th space flight. So he is coming home with a total of 505 days in space.
And in following along with the procedures that the crew are stepping through.
Nose cone secured for entry.
Dragon copy.
And there is that confirmation of nose cone closure that we were standing by for. Now, as we begin the second half of entry, Dragon is now beginning to inject that cooled nitrox or nitrogen-oxygen mixture into the air being delivered to the suits worn by Nicole, Josh, Koichi, and Anna. Again, that's what will allow the crew to remain super comfortable while the external temperatures reach 3,500 degrees Fahrenheit, so a little warm on the outside. That heat shield is pointing forward, leading the capsule to the landing site. And speaking of the heat shield, Dragon's primary heat shield is comprised of PICA 3.0, which stands for Phenolic Impregnated Carbon Ablator. The first generation PICA was actually first developed by NASA for studying and sampling comets within our solar system.
Yeah, so SpaceX partnered with NASA to develop PICA X, which was the second generation product used on all Dragon 1 commercial resupply missions that successfully resupplied the station on on 20 missions. PICA 3.0 was developed specifically for use on Dragon 2 crew and cargo spacecraft with enhanced structural and thermal properties that optimized the heat shield and drove down the cost and mass.
The remainder of Dragon capsule is composed primarily of a SpaceX proprietary ablative material. It's another class of thermal protection, which is lighter weight versus PICA and protects the underlying composite structure during that reentry to ensure that the structural capabilities are maintained.
So while Dragon will experience temperatures well over 3,000 degrees Fahrenheit during peak re-entry conditions, the characteristics of the thermal protection systems, also referred to as TPS, coupled with the environmental cooling and life support system, which we refer to as Eclipse, that's in the pressurized interior, that will ensure that Nicole, Josh, Koichi, and Anna stay cool and comfortable during all phases of re-entry through splashdown.
After Crew Dragon Endurance has re-entered the Earth's atmosphere, a series of parachutes will deploy to slow the crew's descent. The first will be 2 drogue parachutes, followed by the 4 main chutes to guide Dragon to its first contact with Earth since launching in April last year. Dragon will automatically deploy these parachutes when different pressure and positioning sensors on the capsule detect that they are at the right speed and altitude.
The vehicle velocity at the drogue deploy parachute timing is about 350 miles per hour. So they deployed about 18,000 feet. Now the vehicle velocity when the main parachutes deploy is at approximately 119 miles per hour. They'll deploy at about 6,500 feet. And when we have our water splashdown, the spacecraft is traveling cool and comfortable, approximately 16 miles per hour. So the highest G load we expect the crew to experience during reentry is about 3 to 5 Gs. So again, with nose cone closure, we don't have a whole lot of visual changes, like you mentioned, that we will see. And our crew members are already in their suits and in their seats, as we had a preview of earlier. So coming up next will be our anticipated loss of signal around 5:48 p.m. Pacific time. The crew just got an update on that from CORE here in Hawthorne before we started the broadcast. So again, when we're in that entry period and plasma is building up around the spacecraft, it makes it hard for us to communicate back and forth. So during that time, we won't have communication with the astronauts or the spacecraft itself. However, again, Dragon is fully autonomous and continues guiding those crew members to our splashdown site in Tampa.
That's right. That expected loss of signal, or LOS, as you'll hear it called out, is coming up in 14 minutes on the dot, actually. And it's something that happens every time one of the Crew Dragon capsules returns to Earth. It lasts only a few minutes, but it's something that we will hopefully at that time be able to have some views of Dragon as it is re-entering the atmosphere. But of course, after that entry point, like we mentioned before, those parachutes will deploy shortly thereafter, starting with those 2 drogue parachutes, followed by the main parachutes, which are those beautiful orange and white big parachutes that we just love to see during that re-entry.
And of course, the recovery ship tonight that will be recovering the crew from the waters off the coast of Tampa is Shannon, named in honor of Shannon Walker, who flew on the Crew 1 mission back in 2020. Can't believe it's been 3.5 years now.
So at this point in time, as we mentioned before, we are a few minutes away from the next major milestones, about 12 minutes and 45 seconds from that anticipated LOS. We are taking your social questions from social media. If you have one, be sure to use the hashtag AskNASA, and we'll try to get to them as we can. Sometimes, especially after splashdown, there's some waiting periods. So we'd love to take some questions. We have a couple already, so let's check out what that first one is. This one comes to us from Anchari. At what number is the space station at capacity? Are there interactions between the crew from different countries? That's a great question. I think the fact that it's called the International Space Station is definitely indicative of those interactions that take place among the crew while they are on station. I personally love seeing photos of the crew whenever they're sharing meals together. If they can, I've seen photos where they like to bring up food from that is representative of their country or their culture and share it with the other crew members on board. It's just something I love seeing the crew do.
Yeah, absolutely. And of course, different cultures have different holidays as well. So sometimes they share those sorts of traditions. And it's definitely the International Space Station. Sometimes they work together on projects or even on spacewalks. Our JAXA astronaut, Koichi Wakata, went out on, I believe, 2 spacewalks with Nicole Mann, our NASA astronaut, during their stay at the International Space Station. So a lot of working together while they are on board. And of course, there's a lot of work going on the ground between our partner countries as we prepare for these missions. And the question also was a limit to the number of people on the International Space Station. So for the past week, we had 11 people on the space station.
Sounds cozy.
It does. It sounds a little cozy, but the space station is also pretty big. And twice it has housed 13 people. So I don't know that there is a max limit that we have established or determined at this time, but we've seen 13 a couple of times before, and we just wrapped up a full house of 11.
Let's take a look at another one coming to us from Jiu-Jitsu Panda. I love that. Can the astronauts work out or exercise on the space station? Thank you ahead of time. Absolutely. In fact, they have to, right? Yeah. It's required in order to maintain their health, maintain their bone density, which ultimately, keeps them working efficiently while they are on station. But it's also part of the study of how microgravity impacts the human body in terms of, hey, if you do with this exercise, what is the result? Are you still maintaining the level of health necessary.
Yeah, absolutely. And they have a few different exercise machines on the space station. So I was talking with Shiva. There's a treadmill that you have to kind of wear a belt, and it's hooked to the treadmill itself, so that as you're running, you're not kind of floating off with every step you take. There's also a stationary bike, and then there's also the advanced resistive exercise device. We call it ARED. It can be modified so that you can use it to do arm workouts, leg workouts, anything from bicep curls to squats, even ab workouts. So they've done a great job at providing options up there, and the crew members are assigned to each one. So they don't get to choose a favorite and only get on the treadmill every day. They have to make sure that they're also maintaining their muscle mass and their bone density with a little bit of weightlifting as well.
One thing that I never took into consideration until I heard it called out during the Crew 6 docking period was basically the Capcom at Mission Control in Houston, I think, was talking to Josh Cassada. I can't quite remember, but it was speaking to one of the astronauts on station and basically told them, hey, you can't do your workout as scheduled because we're about to dock Crew 6, and just the vibrations created from the exercise in the space station, even though it is a really big floating laboratory, it's not floating, orbiting, it was, I never really thought that it had that much of an impact to other things until we heard that call out during that docking where we were right about to dock, and it was basically like, hey, hold off on your scheduled exercise for right now.
Right. We heard that yesterday as well before undock. So just want to mitigate any of those things that might impart loads on the International Space Station when you're in a dynamic event like a docking or an undocking. But of course, they do try and schedule their workouts around those times.
Yeah. Let's take a look at another question. We have a couple minutes here, about 7.5 minutes until that loss of signal.
SpaceX Dragon, all crew, satchels are secure, restraints tightened, the visors are down.
Dragon, we copy. Visors are down, restraints are tight, and tablets and satchels and loose items are secured.
All right, good call out there, just indicating that the crew has everything in place, locked away, make sure nothing can escape its secure location during the re-entry portion, and the visors are down. So basically the crew is locked and loaded, ready to come home. Taking a look at this question coming to us from Taniko wow, this is tough. Tiniko Tikza Baloy, I apologize for not pronouncing that correctly. When the Dragon approaches Earth, how do you make sure that it does not collide with airplanes in flight? That's a great question. So part of the process to launch a spacecraft or bring it home is basically to get a license from the Federal Aviation Administration, or the FAA, and basically request that airspace and sea space be quarantined off in a keep-out zone, basically, so that aircraft and sea vessels are not in danger during this phase. So, yeah, it's a great question, because you really have to think of, because the Earth is a sphere, it's a globe, it is a three-dimensional process to re-enter the atmosphere. It's not just coming back down to Earth. It is that three-dimensional space, that airspace that has to be cleared and saved, basically. Great question.
That is a good question. And I've seen some pretty amazing pictures before of people in commercial airplanes as they are en route somewhere and can see one of the spacecrafts lift off. So I would love to have that opportunity someday.
Same. Although with how often we're launching out of Cape Canaveral and Kennedy Space Center, it's certainly more likely now than it ever has been to catch a rocket launch from your window seat while flying into Orlando Airport. Another question coming to us, this one from Joshua Green. How do the departing astronauts make sure they don't accidentally leave any of their stuff on the International Space Station? And has anyone forgotten anything up there?
Well, there are checklists to make sure that the astronauts don't leave anything on the space station. And of course, I'm sure something has been left behind at some point, but there's always somebody going up and coming back down. So maybe one of their friends is kind enough to bring it back for them. The crew members themselves have a very limited amount of space of what they can choose to take up. I've heard it referred to as maybe like a shoebox size. So they might take up photos or jewelry or special mementos for their friends or family back home. So those things I'm sure they keep close personal track of. But then additionally, there is a lot of cargo or scientific research that is loaded back onto Dragon before it comes home. So there are teams specifically dedicated to tracking the locations of items on the International Space Station and make sure that our crew members load them up before it's time to come home.
That's a good question.
That is.
Next one coming to us from Sooner Source. My son Dex would like to know how fast the capsule is going when it hits the water. Oh, that's actually a really great question. I'll back up first. When the capsule is on station and when it departs the space station, it's going 17,500 miles per hour or thereabout.
Yes.
It's going really, really fast. And then we do that deorbit burn, which helps to slow the vehicle down significantly. But at that point in time, it's still going, I want to say it's about 500 miles per hour as it re-enters the atmosphere. That heat shield that we talked about before is actually going to do a lot of work that gets converted into the form of heat, that plasma that builds up, and actually slows it down. So the Earth's atmosphere is actually going to help us out in slowing the vehicle down even further as it re-enters the Earth's atmosphere. And then we have those two sets of parachutes.
Dragon, SpaceX for entry briefing.
Go for Dragon.
Okay, just to give you a quick update here for timeline, we are tracking no deltas in terms of vehicle status. Only item to note is that you may get the AGPS alerts when you come back out of blackout. Just wanted to give you an update that if those have the SDC at the end of it, there's no concern. It has no impact on Dragon's automated chute deployment sequence. How copy?
Okay, copy. We may get the APGS alerts if it's got Sierra Delta Charlie. That's no impact.
Those are good words. Other than that, the weather's still looking good, and we're looking forward to getting you home shortly. Expected blackout time is in approximately 2 minutes or so. We'll see you on the other side at 0156 Zulu.
Copy. See you on the other side.
Wow, we got to that anticipated blackout time pretty quickly. So again, that's coming up at about 5:58 p.m. Pacific time, about 5:48 p.m. Pacific time. And so about 30 seconds from now, we will be out of communication with the astronauts and the Crew Dragon capsule during that time. The Corps mentioned an AGPS potential alert coming up after they require signal. That is the absolute global positioning system. They had a couple of pop-ups earlier, but as you heard the Corps tell the crew, those are not of any concern for them. Additionally, I got a good report for everything on Crew Dragon, looking good as we head into this entry period. There was one ground item we were monitoring that the Corps discussed with the crew earlier this evening. The WB-57 will not be available due to a technical issue. Of course, this has no impact on the operations. It isn't necessary for return. Everything continues to go very smoothly. The main purpose that we fly the WB-57 is to collect engineering imagery in addition to what we get from the cameras on the boat. So we will have those cameras on the boat, keeping their eyes out to spot our crew members as soon as they re-enter the Earth's atmosphere.
That's right. Now, after Crew Dragon Endurance has re-entered the Earth's atmosphere, a series of parachutes will deploy to slow the crew's descent. First will be the 2 drogue parachutes, followed by the 4 main chutes to guide Dragon to its first contact with Earth since it launched. Dragon will automatically deploy those parachutes when different pressure and positioning sensors on the capsule detect that they are at the right speed and altitude.
And we were just talking about these speeds. So the velocity at the drogue deploy point, we've slowed down to 350 miles per hour. Those deploy at about 18,000 feet. That is quite different from the 17,500 miles per hour we were just traveling before the deorbit burn.
Yeah.
And then the velocity at the time of main parachute deploy is about 119 miles per hour. Those will deploy at about 6,500 feet. And then that gentle water splashdown, we will be traveling at about 16 miles per hour. So again, that highest G load we think is around 3 to 5 Gs. So they should be pretty comfortable, just monitoring again as all of those parachute deploys are autonomous. Again, we are in that communications blackout period. It's just begun.
That's right. We're expecting that to last about 7 minutes due to the formation of plasma around the spacecraft. During that time, no vehicle telemetry is received by mission control or the recovery team, and no external commanding of the vehicle or voice communication is possible. As a reminder, Dragon is designed to fly itself, though. During reentry, the vehicle will be slowing down from the orbital velocity of 17,500 miles per hour. The top temperature that Dragon will experience upon that reentry, in terms of the exterior temperature, is around 3,500 degrees Fahrenheit. So as we mentioned before, we expect this blackout period to last several minutes. We are basically now in that reentry period, and we anticipate this we anticipate getting that signal back in about 5 minutes from now.
This is moving pretty quickly because we are anticipating those drogue parachutes to deploy at about 5:58 p.m. Pacific time. So really just 7 minutes from now. We're looking at splashdown around 11 minutes from now. So this is a very quick timeline. A lot of things happening in rapid succession as our crew members come home. But again, we've heard good reports so far, and we are awaiting that acquisition of signal in around 4.5 minutes.
Now, one thing that if we were able to get views inside the Dragon capsule, which, like we said before, because of that plasma buildup, we are unable to get those views. But if you were watching earlier in the webcast, you did see those crew displays, those touchscreen panels that the crew was using to monitor the health of the capsule, the state of what was, the state of command for what the Dragon capsule was actually executing. As of right now, they also now have a little map that shows where they are and how much further they have to go for this reentry. They will be able to follow along with the anticipated deployment of those parachutes. One thing that the crew is trained to do is be aware of the surroundings. And of course, when those parachutes deploy, because they are slowing the capsule down, there is a small jolt that occurs during that deployment. And so, and also whenever they splash down, you'll also hear brace for splashdown or brace for impact. That is just the crew being aware and just getting ready, holding on to their seats for those moments where there's a little bit more of a noticeable feel to where they are in their seats.
Right, and I think it's very interesting after watching so many splashdowns, whenever we have main parachute deploy, they don't open to their full ballooned shape right away. They do something called reefing. So they open up quite slowly, or sometimes it appears that way. That way, that jolt is not, it's not exaggerated any more than it has to be. So they open up slowly and slow the spacecraft down again to about 16 miles per hour.
Again, we're in the anticipated loss of signal. There's 2 minutes or about somewhere between 2 and 3.5 minutes remaining. Sometimes it's hard to tell exactly when we'll be able to get that signal back, but in about 3 minutes, we will start hearing the core reach out to the crew to see if they can make that connection. Once again, the loss of signal is expected, totally normal due to that buildup of plasma around the exterior of the capsule.
And we also have our recovery teams already on site, already on Shannon, the SpaceX recovery ship, and that is waiting off the coast of Tampa. Some of those team members arrived by helicopter. We have one of our NASA public affairs officers also on.
And there's our first view of the Crew 5 crew in Dragon Endurance re-entering the Earth's atmosphere.
So this is a view from the recovery ship itself of Crew Dragon re-entering Earth's atmosphere. Of course, we still do not have communication with them because you can see that plasma buildup as they are coming through the atmosphere, that heat shield doing all of the work to ablate that heat as it builds up around the capsule. So again, as we mentioned, you see the movements here. That's the ship camera moving and continuing to track the spacecraft during re-entry. We anticipate reacquisition of signal in just a couple of minutes from now. As Kate mentioned, it can vary on when we get that timing. But great to already have a view of our 3 astronauts and 1 cosmonaut inside as they are headed home. There will also be a couple of sonic booms during that time frame.
Dragon, SpaceX, comm check.
As I mentioned, the SpaceX core.
SpaceX Dragon, we have you loud and clear.
We have you the same. Good to have you back. Expect automated chute deployment.
Dragon, copy.
It's incredible to know that the voice we're hearing is coming from that gorgeous ball of light.
And all of the other little points of light you see around it, they appear to be streaking on the camera a little bit. Those are stars. Obviously, that beautiful bright light in the middle, that's Crew Dragon Endurance coming home after 157 days in space. We are standing by for drogue parachute deployment. That'll be in about 2 minutes, but we already do have acquisition of signal. That came, again, a little bit earlier than we expected. So
that's right.
It is a little hard to target sometimes.
GPS has converged. Expect nominal altitude for drogue chute deploy.
Dragon, copy.
Again, that point of light in the center of your screen, that is Dragon Endurance. Another, a different view. This one infrared coming from the recovery ship. As we were mentioning, all of those team members that are ready to recover the astronauts are on the ship. They're in position. It'll take just a little bit for them to move in toward the capsule once it lands, but they all have a very important and distinct role to play, either retrieving the capsule or helping the astronauts egress, and they are all standing by.
At this point in time, Dragon Endurance is about to deploy the drogue parachutes. Those automatically deploy around the 18,000 foot mark, and the capsule's going about 350 miles per hour.
Brace for drogue window.
Dragon, brace.
So just a call out there to let the crew know that they are approaching that window where the drogue parachutes will automatically deploy.
And just prior to the deployment, Dragon automatically safes the propulsion system and then deploys the parachutes to stabilize and help decelerate the spacecraft.
So like we said, we're getting ready for those drogue parachutes to deploy on Dragon. That occurs automatically when it's about 18,000 feet above the ocean surface, and the capsule is going roughly 350 miles per hour. In that view before, there was a difference in, here we can see, it's no longer quite streaking like it was just moments ago, or minutes ago, I should say. Like I said before, it looks like those drogue deploys are now Yep. We got
visual on 2 healthy drogues.
Dragon copy.
As you can see with that infrared view, we have 2 healthy drogue parachutes on Dragon. There's a view from Dragon looking up at the drogue chutes.
Those will remain attached to the spacecraft until they help deploy the main parachutes, coming up in just a few moments. Again, these views coming to us from the recovery ship standing by to recover our crew members once they splash down. Looks like we
it looks like we have main parachute deployment there.
Main chute descent rate nominal.
Dragon copies, 1,000 meters.
Beautiful.
Copy, 1,000.
Beautiful view there from that recovery vessel of Dragon Endurance with those 4 healthy main parachutes. At this point in time, the capsule is going about 119, or was going about 119 miles per hour when those were deployed, and they also deployed about 6,500 feet. So these main parachutes will help slow the vehicle down even further to about
800 meters.
Copy, 800.
So that we'll hear from the crew about how far they are above the surface of the water. So there we just heard that call out for 800 meters. The capsule is slowing down further and further. By the time that it actually splashes down, it'll only be going about 16 miles per hour.
It's fascinating to think that just minutes ago, really, they were in outer space.
Copy, 600.
And are now just 600 meters above Earth. Again, we are targeting a 9:02 p.m. Eastern Time, splashdown 6:02 p.m. Pacific. So that is the next major milestone for us today, now that we have 4 healthy main parachutes all deployed. Things continue to look good aboard Dragon.
That's right. We're about a little less than a minute and a half away from the crew splashing down.
Copy, 400 meters.
Once again, we are targeting a splashdown off the coast of Florida, near Tampa. So this is what we would consider a Gulf landing.
And those strobes of light on your screen, those are spotlights coming from the recovery vessels as they continue to track Dragon Endurance.
200 meters, crew brace for splashdown.
Copy, 200 and braced.
Commander Nicole Mann giving out that call as we are standing by for splashdown off the coast of Tampa, Florida.
There we can see the water surface. Dragon Endurance coming closer and closer. And as you just saw, splashdown of Crew 5.
157 days in space.
SpaceX Dragon splashdown. Names have been released.
Copy, Dragon. We concur with splashdown and mains released. Dragon Endurance, on behalf of SpaceX, welcome home.
As you can see on your screen, visual confirmation for splashdown.
Thank you, SpaceX. That was on one heck of a ride. We're happy to be home. Looking forward to next time.
Dragon Endurance has returned home, and NASA astronauts Nicole Mann and Josh Cassada, JAXA astronaut Koichi Wakata, and Roscosmos cosmonaut Anna Kikina are back on Earth after an approximately 19-hour return journey from space. The SpaceX recovery ship and team has been waiting for Dragon's splashdown, and now, as you can see, they're making their way to that splashdown location.
Right, and these teams have been ready and been waiting about 3 nautical miles away, so it'll take them around 30 minutes to make their way to Nicole, Josh, Koichi, and Anna inside Dragon. We will be listening for Mission Control Hawthorne to give the go for the safe approach now that we have splashdown. There are several different roles. There is an approach boat that will begin inspections. They want to make sure that there aren't any hypergalls, monomethylhydrazine, and nitrogen tetroxide still lingering around the spacecraft. That way it is safe for the teams to move in even closer and retrieve it.
Yeah, the crew will basically approach the capsule and they use what's basically a sniffing device, a device that can detect those levels of MMH and NTO. They are toxic to breathe, and so this is a super important step to complete.
SpaceX Dragon looks like we are in stable 1, although a little tough.
Copy that, Dragon. We concur, and I'm happy to report that the recovery personnel have also confirmed stable 1.
Awesome, thank you.
So just some communication there back and forth with SpaceX Core Michael Blasco and Capsule Commander Nicole Mann, just to confirm the landing position of the capsule itself. As we can see there on your screen, even better now with that spotlight, the crew, the recovery team is approaching the capsule. They are going to make sure that that monomethylhydrazine and nitrogen tetroxide is not present on the exterior of the vehicle. There could potentially be traces due to the fact that those are the thrusters that Dragon was using while in orbit, and so we want to make sure that there aren't any traces of those fumes, basically, so that the team can get close to the capsule. We will actually see an individual climbing on top of the capsule to secure the harnesses that are necessary, the rigging, to lift the capsule onto the recovery vessel. As I have said before, certainly a job that I would not be fit to do, as it involves, as it requires jumping into what we can see as dark water, and climbing on top of the capsule and securing those harnesses.
Where's your sense of adventure? As we heard the core and the crew communicate, the capsule is in stable 1. That means it's in an upright position in the water. Makes it easier to recover, obviously. That is the ideal splashdown position for the capsule itself. So the crew members are still inside. They are still in their suits, in their seats. They will remain that way until the spacecraft itself is lifted onto the recovery vessel. But the first ships arrive are those fast boats. Again, they are just checking out the spacecraft, making sure that it's safe for the rest of the team to approach.
So for those of you that have just recently joined, the Crew 5 team has splashed down off the coast of Tampa, Florida. That occurred just minutes ago, and the recovery teams are now moving into place.
And we're anticipating that those first approach boats will arrive at the capsule just a few minutes from now.
Dragon, SpaceX is go for recovery personnel to approach. Expect personnel alongside Dragon in 1 minute.
Dragon copy.
SpaceX Core just giving the crew a heads up. Hey, you might be seeing some people on the outside of the capsule. It's to be expected.
Yeah, first people that they've seen on Earth, in almost 6 months.
That's right. 157 days in space. Now complete as Dragon Endurance with the Crew 5 crew. Now safely back on Earth. Communications is Leah Cheshire.
Thanks, Kate. It's always great to be here, and of course, another exciting day bringing a crew back from the International Space Station. So upon departing the station, Dragon underwent a sequence of departure burns. Since then, the crew had a rest period and has since kicked off preparations for re-entry. Things are sounding pretty good so far. So in this next phase of the mission is when things really ramp up and happen pretty quickly. Dragon has a series of steps to complete before returning Crew 5 back to Earth.
First, Dragon will maneuver to the correct attitude and jettison its trunk, which is the cylindrical, unpressurized part of the spacecraft. The trunk is currently connected to the aft or the bottom section of the Dragon capsule, where the heat shield is located. So in order to expose that heat shield and get the vehicle ready for atmospheric re-entry, we'll jettison that trunk.
And just a quick look right now inside Crew Dragon with our Commander Nicole Mann on the left and pilot Josh Cassada on the right. After we jettison that trunk, we're looking for that to come up